Provisioning at the Speed of Thought, an introduction to Ansible, Salt, and Puppet. For those of you who don't know or are visiting this class for the first time, my name is Robert Underwood. So just to kind of give you an overview of what we're going to talk about today, is we're going to talk about what is provisioning, why you might want to do it, and then we're going to talk about 3 of the most popular tools in order to do software provisioning on various systems. So I'm going to be talking about Puppet, Ansible, and Salt. But without further ado, I want to kind of motivate why anyone should actually care about tools like this. And to kind of give you an idea, how many of you have ever installed or worked on more than one computer at a time? Okay, most of you. How many of you really get annoyed by the fact like, oh, I need to install X on all of them?
It was a while ago and I used Clonezilla.
Yeah. So once you start installing software on more than 2 or 3 computers, it really starts to get unwieldy, especially if you get up to 5 or 100 computers, and if the configurations for them are just slightly different, and then you have to, like, for example, go and set the hostname file on every single computer, that gets really obnoxious really fast. And then what if you get a new computer, and that computer also needs a slightly different image? Like, do you have to maintain all of these different image files that all describe how to set up the computer, or you either have to go through and manually set all these things up, and by the time you're done with all of this, you're just going to have massive carpal tunnel. It's just not fun. I do not recommend it at all. Also, how many of you who've worked with a large number of machines have that one machine that you always forget to install the updates on? Okay. Most of the people who said that they install software on multiple machines. So provisioning systems and some of these configuration management systems that I'm talking about today help to solve these problems by making it easy to, from a single console, control and update all of the machines in your network or domain. This can really make your life as a system administrator a lot easier, and I think will be important whether you go into industry or in academia where you're trying to do experimental computer science or just managing large number of machines. So what is provisioning? So provisioning is basically software that allows you to manage files, users, and software that are installed on machines. Most of these systems have some concept of what are called facts. Facts are basically ways of querying state about the computers that exist on the network. Things like their host name, or what users happen to be installed on the system, or what software packages are installed, or what version of a particular piece of software that's installed. Many of these systems, specifically Ansible and Saltstack, have features for provisioning cloud instances. How many of you have heard of AWS? Okay. So a lot of these systems have tools within them. If you need to go set up a bunch of nodes on AWS, you can do that directly through these systems. And then once you've created the nodes, you can then put software that you need to use on the nodes and different things of that sort. And you can also configure these systems to automatically install themselves on new machines inside of your managed network. So they can really save you a lot of time as a system administrator who's working with more than just a few machines. So how do I get started? So this section is going to take the majority of the presentation, and I'm going to walk you through kind of what some basic configuration looks like in each of these tools and why you might want to choose one of these tools over the others. I'm going to start out with Puppet, and kind of the reason for this is I'm going to take you chronologically through my experience with provisioning systems. So Puppet was probably the first of the systems that you'll see to do this kind of task, and it was the first one that I worked with. Puppet is written in the Ruby programming language. The reason why this matters is if you want to extend Puppet to do new things, you have to use Ruby to do so.
Configuration in Ruby too?
Chef is, but Puppet is not, and I'll get to explaining that in a second. Unlike most of the other systems, you have kind of what's called a master agent architecture. So in this sense, you're having to install some piece of software called an agent on each of the client nodes in the system. It's still requiring you to have to install something, but this is something that you might, for example, as Foster suggested earlier, put on your disk image that you're distributing out to all of your nodes. So you have this common base level of software that you're distributing, and then you would use Ansible or Puppet or Saltstack to kind of manage the additional things on top of that. So that's kind of what Puppet does. One of the other key differences that I want to point out about Puppet relative to the other systems that we'll talk about is Puppet does out-of-order processing. How many of you have taken a computer architecture class and heard about out-of-order processing before? Okay, so a couple of you. For those of you who don't know what out-of-order processing means, is it's going to basically have a giant queue of tasks, and that queue is in no particular order. So it's going to install those or run the various tasks that are in the queue, only subject to the dependencies that you explicitly declare that exist between them. Otherwise, it'll do as much as it possibly can in parallel. For this reason, Puppet is the fastest of the tools that I'll be talking about today, because it can kind of parallelize this task and do work in parallel. Configuration for nodes managed in Puppet is done in a special language called, oddly enough, Puppet. For those of you who don't know what Puppet is, it's a kind of this weird mix of what I would describe as object-oriented and declarative programming methodologies. If you've used Prolog, you might, or some of the languages, maybe SQL, you'll have a rough idea of what I mean by a declarative programming language. So this is what some Puppet actually would look like. So in this example, we declare a resource of type user with a instantiation ID of ACM. So in this case, we're creating a user called ACM. So we're going to ensure that the ACM user is present on the system. We're going to create a home directory for them. We're going to have them use the bash shell, put them in the ACM group, and then this last line here indicates that we're creating a dependency on a group called ACM. Here, we're creating an additional resource of type group for the group ACM. So notice what has to be unique is kind of the combination of these two elements. So you can only have one resource of any particular type with a given key. So for example, we couldn't have two users called ACM, but we could have a user and a group called ACM. Also, unlike most programming languages that you're used to, you'll notice that the group and the user are not in order. So the reason why that's okay, though, is because we're using the out-of-order processing by declaring the dependencies in the user resource. There's several different ways that you can do this. If you have more than one user or a small number of users, you can also use variables in other systems that you might be familiar with. For example, here, we define a users variable containing 3 users, ACM, foo, and bar, all of which will be part of the ACM group. So in the user resource, instead of giving it a key, we're going to pass it the variable that we created earlier. And that variable will then instantiate 3 user class or user type resources corresponding to ACM, foo, and bar, all with the ACM group. Now, this is one of the weird things about Puppet, but also one of the essential things to understand. Puppet has this concept of what are called universal collectors. That's what this funky operator here looks like. And that's what it means. It's sometimes also called the spaceship operator, because people have senses of humor, I guess. But what this is saying is all of the group classes are required for all of the user classes. So any group resources that we instantiate, or any of the user resources that we just instantiate, need to be instantiated after we've instantiated all of the group resources. If you don't use these universal collectors in Puppet, you're going to have enormously long Puppet scripts. So it's a really important and a fundamental concept of Puppet to understand. You can also use it to manage software. So here we're installing the best editor of all time, Vim, on systems. And what we're doing is we're going to parameterize what Vim package we install based off what operating system family we might happen to be on. So on the Red Hat family of operating systems, we want Vim X11, which is what it is on CentOS, on Fedora, things like that. On Debian-based operating systems, things like Ubuntu, Debian, it's called Vim GTK3, because people can't agree on names of packages to save their lives. I'm sure it's something else in Gentoo.
No, it's just Vim. You
Okay.
just had the GTK use flag if you want GTK.
Okay. Anyway, moral of the story is most other distributions that don't call it one of these two things just call it gvim, and then you have everything you need. So here we're using the variable that we defined and then querying a fact about the operating system that we happen to be installing upon. This variable is set by the factor component, the fact-finding component of Puppet called factor. Here, we're declaring a package resource of key gvim, and notice that we've set this name parameter. By setting this name parameter, it's going to template in the appropriate package, whether it's vimx11, vimgtk3, or gvim, depending on the operating system, and make sure we always have the latest version, because no one likes to have an old version of vim. Okay? The last thing that you might care about is something like a service. This is going to be something that's like a long-running process that you might have running in the background. So here, we're using this to manage the SSH daemon config. So we're making sure that it's a file, as opposed to like a directory or a symlink. We're ensuring that it's owned by the root user, that other people can read it, but no one else can write to it. And then we're going to load in a template for this SSH config from a config file that we have in our system. On Puppet, there are two template languages that you can use, the most common of which is called ERB, which is the templating language that's built into Ruby. So that's kind of the idea here. The other thing that I want to point out is we have another type of dependency than what I described earlier. Here we have kind of a pub sub or a notify subscribe style dependency. What makes this different from the requires style dependency that we saw earlier is this service dependency might not always execute. It's only going to be executed when it's notified via the notify command. So this way, for example, you only restart your SSH daemon whenever you change the configuration. You don't want to restart it just willy-nilly. So as I said, you have a very clear, explainable format. This is how you kind of declare a specific resource that you might have. Notice the difference in capitalization in the word file here and the word file here. That's not an accident. Puppet is case sensitive. So this corresponds to like a type, like int or float. This corresponds to a specifically instantiated file. Any questions so far? Any of the kind of basic provisioning concepts that I've gone through before I kind of go into the pluses and minuses of Puppet specifically? There's one other thing that's commonly used in systems like Puppet is kind of this ability to provide additional facts that are not provided by the system. Like for example, I really care about what version of Git is installed on my system. So what I've done here is I've written out a bit of Python code that will go and query what version of Git that I happen to have installed on my computer. So I might have a fact like this that I want to distribute and then use. Here would be the additional bit of code that I would need to in order to hook this into Puppet. So Puppet could then query and use the Git version information elsewhere in the system. So basically, you're just going to print out key value pairs that are separated by an equal sign corresponding to the facts that you care about. Okay. We're going to be using that same Python code. It's not important that you know exactly what's in it. It's more there for future reference if you wanted to use these slides to help start writing your own external facts. Okay. Most of these systems provide some way of kind of creating modular units of configuration. So Puppet calls these modular units of configurations modules, and this is kind of roughly what the layout of a module might look like. So you can generate this layout automatically from the Puppet command line tool. Puppet module will generate name of module that you want to make. And then this will create a directory that looks like this. Manifests, that's the Puppet files like I've been showing you so far. That's how you specify configuration about a particular thing. So for example, we might make a SSH daemon configuration module. So we might call it mySSHD. So in the manifest, we would have a specification that says, make sure you create the SSHD config file, make sure you generate the SSH host keys, and go ahead and install the SSH service and make sure it's already started. So that's kind of what manifests do. Files are static files. These are files that are not templated. So for example, if you had like, I don't know, like a list of facts or some arbitrary information, like a message of the day that you wanted to install on every machine that you managed, If you didn't want to template that information, you would put that in files. Things that would be templated, for example, the SSHD config file, would go in templates. If you wanted to write any extensions that are specific to your SSHD class, maybe you want to get some information from your load balancer or whatever as part of your SSHD config, you might put that in your lib directory. Any non-Ruby written facts go in facts.d. Puppet recommends that you provide some examples for how to use your modules. Those go in examples. Puppet, unlike all of the other ones, also provides a framework for testing your Puppet config files. I'm not entirely sure why they do this, but it is something that you should be aware about. The tests that you would write for this are using the built-in Ruby unit test suite called RSpec. Good things about Puppet is it's really good for weird systems. So if you have like some random ASA firewall device or random like embedded networking device that you have to interface with, or like an AIX machine, Puppet is actually going to have the best chance of working reliably on those systems to manage those systems. It also has the most community modules that are already available. So people have gone and published modules to do all sorts of different things. You can find those on what's called the Puppet Forge. The out-of-order processing gives it performance that's far and above every other configuration management tool that we've listed. And finally, it's available under an open source Apache license, so you can pretty much modify the code without having to redistribute your secret sauce back to Puppet Inc., the group that maintains Puppet. The bad, for me personally, it's written in Ruby, and I'm a Python guy. There's a little bit of a holy war there for those of you who are not familiar with the conflict between Ruby and Python, but for me it was another step that I had to learn. Additional thing is out-of-order processing, if you're not careful, can lead you both to some really great speedups, but it can also cause you to write some really convoluted code in order to get there, or if you're not careful and you don't write the appropriate requirements and dependencies between the different modules, you can end up with inconsistent states on your system because Puppet won't make any assumptions based off the ordering that you specify in the files or things of that nature. Additionally, out of all of the tools that I'll be talking about today, Puppet's provided documentation is by far and away the worst documentation of any project I've ever encountered, except for the Linux kernel, which has practically none. There is a directory of documentation, but the Puppet documentation isn't much better. I really do not like the documentation that's provided with upstream Puppet. At the end of the presentation, I'll point you to some of the most useful aspects of the Puppet documentation so you can kind of swim through some of the sludge to find the useful pieces that are there in their documentation. Ansible is the next kind of tool that I want to talk about. Ansible is probably my second favorite out of the three that we'll be talking about. So the reason that motivated me to move from Puppet to Ansible was I got tired of writing Puppet. The language Puppet is gross and disgusting, and the documentation is just not there. It's gotten better with the release of Puppets 4 and 5, but it's still just very, very hard to use, in my opinion. Ansible is currently written in Python 2.7x, but is currently being ported to Python 3. Unlike Puppet, it uses what's called an agentless architecture. That means you don't have to install anything on machines that you want to manage. This makes it really useful, for example, if you're doing an experiment, like you're doing experimental computer science, where you're going to be spinning up new nodes on, say, Cloud Lab, or you maybe don't have administrative permission to install stuff, like, for example, on Palmetto or one of the other systems, but you still want to be able to manage the nodes that you currently have control over. Ansible is really good for that because it only requires two dependencies, Python 2.7 and OpenSSH. With those two things, you can actually use Ansible. Additionally, it does in-order processing of modules with this caveat that I'm going to describe as dependencies. So you can specify dependencies in Ansible, but if you don't specify dependencies, it will process your file from top to bottom. So you can avoid a lot of error messages that way. Lastly, unlike the system that I described earlier, which has its own domain-specific language for provisioning and configuring nodes, Ansible is configured in YAML, which stands for YAML Ain't a Markup Language.
No, it's yet another markup language, isn't it?
I thought it was YAML Ain't a Markup Language. But anyway, YAML is a la JSON in kind of how it's expressed, but it's a little more verbose. There's a little more features in YAML than in JSON. YAML is actually a superset of JSON.
Yeah, you get another markup language.
Okay. And Jinja is a templating language which is used very commonly on Python systems.
They changed it.
Yep. So, without further ado, I'm going to take you through basically the same example that I showed you for Puppet with equivalent code for Ansible and then later with Saltstack. So here we're creating the group, so we say name, and we don't even have to provide this name line. This is just providing some useful debug information as Ansible is chugging along and applying our configuration. So it'll print out the name, or the text, create ACM group, while it's creating the group on the system, or all of the systems for the ACM user. Then we're going to say create users. This kind of curly brace item, this is how Ansible does iteration. So if you want to provide multiple things, for example, ACM foo and bar, each of these is going to be in turn kind of placed into this line. And for most modules, the way this works is we'll execute the module multiple times, once for each of the different configurations that are specified in the with items. Some of the modules, like for example, the package installation modules, will actually batch these configurations in together, but most of them do not. So as you can see, this is already much more concise than what we had for Puppet. Here's kind of a grosser way to do the equivalent Puppet code that we talked about earlier, where we're installing the appropriate version of Vim. Here, we're using a conditional on the Ansible OS family to figure out which configuration we're interested in. So again, the same kind of syntax, but there's actually a cleaner way of doing this. And that's by doing this. So by creating a group vars section here, we can put all of the configuration for the Red Hat hosts in one place. For example, here, whenever we refer to a gvim key, provide x11, vim x11. If we're on Debian, do vim gtk3. And then we can only provide these 3 lines in our actual config file. And we would say group by key, OS, Ansible family. So then it's going to group them by each Ansible configuration. And then each group will then dynamically pick up these additional values that we specified in our configuration. So then we can have a single line that installs gvim across all of our different versions. So it's a much cleaner syntax than what you might see for Puppet. Here's an equivalent state for describing how to do SSH. So we're managing the config file. That looks roughly the same of what you probably would have seen in Puppet. The part that gets useful, though, is where you see this notify restart SSHD. Ansible, instead of having pub sub, has kind of this concept of handlers. And handlers are additional tasks that are run optionally after all of your other tasks have been run. So in this case, we define a handler, and we match the handlers based off the name that is specified. So when we say notify restart SSHD, it will look through all of the handlers and run the ones that have names that match notify lines on commands that were run during our configuration. So again, it's just a little bit simpler than what you saw with Puppet. If we want to provide additional facts in Ansible, this is again referring back to this Git version right here is referring to that code that I showed you earlier in Puppet. So what you do is basically you will return a Python dictionary with 2 keys at a minimum. One, changed, corresponding to whether or not this changed state on the computer. Since this is a facts-based module, obviously no changes are going to be made. And then Ansible Facts is a key that says anything that is any value which is attached to this value, expose it so Ansible can use it as a fact elsewhere in the file. And then after that, you just print a JSON structure corresponding to this information. So writing an extension for Ansible is actually super concise. All you have to do is parse JSON as input and output JSON as output. You can write it in any programming language that you like. It's super easy to do. You can even manage it with Windows, or manage Windows systems in a very similar fashion by parsing in a JSON object, parsing out JSON, and writing the script in PowerShell or ASP.NET or what other Windows-based framework you might be interested in using. Ansible also has the concept of modules, except for theirs are called roles. And you only need to create the directories that you need. In Puppet, if you don't create the directories, it won't work. So directories that you would create would be tasks, which is where you would specify the configuration. This is like the specs file in Puppet. Handlers is for those, basically the notification receivers. Library is where you would put any custom code that you need based off a specific task or module. Templates and files are the same. Vars is for variables that are specific to your module. So for example, you might have the variables defined for each OS type in the vars directory. Defaults is basically the same thing as vars, but it has a slightly lower precedence. It just makes for some cleaner setting of default arguments. And then finally, meta is how you specify those dependencies that I talked about earlier that will do the gross reordering of modules apart from how they're listed explicitly in your configuration. Benefits of Ansible is it's agentless, which means that you can run it on practically any system that has OpenSSH and Python. Its documentation, unlike Ansible's, unlike Puppet's, is fantastic. It's some of the best documentation for any tool of its sort. It's very simple and concise with its YAML-style configs. For me, Python was a very useful plus because it was very easy for me to start writing new modules. Another really big feature of Ansible is Ansible Vault. Ansible Vault basically allows you to encrypt files with an AES key and then use that AES key data to basically provide encrypted input values for the different scripts that you might be using. One reason why this might be handy is, let's say you wanted to distribute like a private key as part of your configuration. In Ansible, it will actually encrypt the private key in addition to whatever additional encryption you might do. That way, if the key happens to be found in the wild, it's encrypted and the user can't do anything without the key file. So for a security perspective, Ansible Vault is a huge step forward compared to anything else that the other systems offer. It's also GPL licensed, which is one of the most commonly used open source licenses, and what I like to use on my own personal projects. Downsides of Ansible is it's significantly slower than Puppet, and there were a number of regressions that happened when we went from Ansible 1.0 to Ansible 2.0. Ansible is very opinionated. There's very much a right and a wrong way to do something. And if you do it the wrong way, you'll notice by exactly how much code you write. So the right way, quote unquote, of doing something will be really, really short. The wrong way will take you pages. So knowing what Ansible is expecting is probably useful to know. I also say that it is less featureful than some of the other options, primarily because it doesn't provide some of the features for managing, for example, like AIX boxes or something like that. Okay. Any questions on why you might use Ansible or comments on what I've kind of presented so far? Okay. So now I'm going to move on to Saltstack. Saltstack, basically about the time that all of the regression started happening in Ansible, I started looking for another perhaps more concise, easier to use system. And that's when I found Saltstack. Also, around this time, I was hearing lots of chatter about Saltstack on different open source news podcasts that I listen to, such as the Jupiter Broadcasting Network. So I found Saltstack as part of my explorations there. So Saltstack is written in Python 2.7.x, just like Ansible, and is also moving to 3.x. I would say compared to Ansible, they're a little farther behind in the transition to Python 3, but not by much. Saltstack, unlike Ansible, is what I'll call a mixed architecture. So Saltstack provides two methods for running or provisioning nodes. There's a traditional master agent architecture that you can use, which is really, really fast, but you have to have installation privileges on the nodes that you're managing, which you might not always have. On the other hand, there's also what's called Salt SSH, and Salt SSH works exactly like Ansible's SSH. Now, in practice, I found that Salt SSH is a little buggy compared to Ansible's SSH configuration. But for most users, it will suit all of the needs that you have for example, managing like an experimental network that you might spin up or spin down on Cloud Lab or Palmetto. It uses what I'll call computed ordering. So this is kind of a happy medium in between the strict out-of-order processing of Puppet and the strict in-order processing of Ansible. So it knows kind of intuitively what certain things should have or should not have dependencies, and will make some intelligent decisions based off of that. If you want to view the ordering that Saltstack is going to use to do things in parallel or not, you can actually ask it to print that ordering out. Saltstack is configured primarily in YAML with extensions written in Jinja or Python. The reason why that might be useful is if you have a highly programmatic or a highly variable configuration landscape that you're managing, you might just write your Saltstack code directly in Python. And that is a completely supported way of doing things, as opposed to, say, Ansible, which really expects you to write it in YAML or kind of halfway in between YAML and Python. So much more powerful in terms of the language that you're going to use to express modules. This is how we would express the same code that we saw earlier for creating the ACM user with the foo and bar users. So ACM group.present. So this is saying for the ACM group, ensure that they're present. And then for users, we're going to ensure that each of these three users is present. So it's a little bit of a simpler interface. If you're familiar at all with Jinja, this will make a lot of sense and be very familiar and comfortable for you. Here's kind of the quote-unquote bad Puppet-like way of kind of doing templating based off packages. You can literally just have if, else if in your configuration syntax. So for someone who's used to like a C or a C++ or a traditional programming language, this will probably be the most comfortable way. And this actually does work. It's a little slow, but it's actually doable. The better way of doing it is in your Salt file, you'll say pillar. Pillar is Saltstack's version of facts about a file. And it's going to basically look up the gvim key in there and then make sure that that package is installed. That file is going to look like this, and then once for all of the groups that you might have on your system, you'll define one like this called top.sls, which kind of configures what order it should search for facts about different resources. For here, it's going to look at the default information for Red Hat and then information for Debian, kind of in that order. Okay. This is how you would manage an SSH config. Again, it's about as concise as what you saw with Ansible, and syntax-wise, it's going to look fairly similar. External facts are actually much easier than they were even in Ansible. In Saltstack, every Python function that is not prefixed by 2 underscores, as long as it returns a dictionary, exposes facts as part of a Salt module. So that's really easy, really useful, and can give you a lot of information, make it very easy to extend Saltstack. Saltstack, other than the file called init.sls, the names don't matter. So you can structure your directories however you want or however you need. It's the most forgiving on that front. Init.sls is kind of, think of it as main for all intents and purposes. That's whenever you reference the module elsewhere in configuration. By default, that's the one that's going to get run. All of the other ones, you can reference them by, for example, mymodule.variant or mymodule.variant1 to reference those files. And then you can have a subdirectory with any additional configuration that you might need. The goods about Saltstack is compared to Ansible, it is significantly faster. Jinja plus YAML is like a match made in heaven. It's super handy and can get you much more concise ways of expressing certain types of information than the way that you would have to express equivalent information in Puppet or in Ansible. It's master-slave as the default architecture, but Ansible or Saltstack provides facilities, unlike Puppet, that make it very painless. So it's very easy to add new nodes to your cluster. It even provides a script to bootstrap them via SSH. It's very simple and concise. Another very important factor about Saltstack compared to the others is it has kind of the concepts of reactions and provisioning as kind of first-class citizens as part of the provisioning system. So to explain those very quickly, provisioning is when I talked about like allocating cloud resources. In Saltstack, you can literally just say, give me a EC2 C3.xlarge compute instance on AWS. Here's my key. And then once you're done, apply these configurations to it. Super simple. Reactions is kind of the concept of, oh, my EC2 load balancer has told me that I have a ton of load and all of my servers are at 90% of their utilization. So I need to react to that by spinning up 3 additional compute instances. So this concept of having reactions based off activities that are happening on your nodes, this is the only system that I'm familiar with that provides this kind of feature within the provisioning system. It's also written in Python, which makes it very easy to get started with. It's also Apache licensed like Puppet, so you don't have to worry about necessarily contributing your updates upstream. The bad, so while their documentation is actually usable, unlike Puppet's, it lacks organization. So what you're probably going to want to do is download all of the documentation and then use grep or whatever other search tool you're familiar with to find what you're looking for in the documentation, because it's not particularly organized well to find it just kind of coming through it. Additionally, for those of you who've used Jinja, there's no facilities for doing custom Jinja filters. This is basically a way that you can modify iterators in Jinja. If you're familiar with that, you'll see this as kind of an annoying little limitation on a system that's otherwise very modular and gives you a lot of power and control over your configuration. So for some further references that I'd like to point out, this is the link to the Puppet source page, and then I've provided, these are basically the 3 most important pages in the Puppet documentation. The visual index kind of gives you a summary of how to express different things in Puppet. The type reference is an exhaustive list of all of the pre-built configurations that already exist. So between those 2 documents, you'll find most of the stuff that you'll need in order to make a working Puppet configuration. You will also want to very clearly read the information on Factor and Huayra. Huayra is kind of the tool that Puppet uses to assign configuration collections to nodes. Factor is how it gathers information about nodes. In order to use Puppet effectively, you're going to have to use both of these tools. Whereas in Saltstack and Ansible, they're built into the configuration system already on their own. And then I've linked to the Ansible and the Salt documentation as well. So at this point, I'd like to open the floor for any questions on why you might use some of these tools, what kind of features you would like to know how to express using these, things of that nature. Does anybody have any questions? Parker.
So you didn't mention which one was your favorite, I think, but I assume that you went in order from least favorite to most favorite. Is that correct?
Almost. So I really like both Ansible and Saltstack. Saltstack is what I use for my personal configuration, but I'm currently using Ansible for work. And there's a reason why. And the reason is Ansible's stateless configuration or agentless configuration makes it much easier to work with systems like Cloud Lab, which is a key part of the workflow that I do for my research here at Clemson. So being able to just set up nodes on the fly and not have to install an agent on them really saves me a lot of time compared to what I would have to do in order to manage the same kind of a system using Saltstack. But for personal systems, Saltstack's the tool that I have of choice.
So which one would you suggest to someone who needs, like, to manage a medium amount of systems and hasn't used one previously?
Okay, so I would recommend either Saltstack or Ansible. And it depends on whether or not you're going to have a significant number of systems in your cluster or in your management domain that you won't have root access on. If you won't have root access on a machine, I would recommend Ansible as the better choice, because Saltstack kind of assumes that you have administrative privileges in order to do a lot of the tasks that it's looking for. That's not to say that you can't use it without those, but it really does. For example, you have to jump through a bunch of hoops in order to use Saltstack as a non-root user, whereas Ansible it doesn't care. it will just let you do it. So does that answer your question, Parker?
Yes, it is.
Okay.